Rick Tribuno's lab is creating and measuring some of the shortest events ever, laser pulses as short as a few millionths of a billionth of a second long. Rick has several colorful analogies for this length of time. For example, one of these pulses is to 1 second as 1 nickel is to the entire U.S. national debt. Graduate student Pamela Boland took us on a tour of Rick's lab. All the lasers and mirrors are bolted tightly to a foot-thick steel table, because if any mirror or lens is even slightly off, it could spoil a measurement. Even the slightest breeze from someone walking by could move a mirror, delaying a pulse by an eternity, at least according to the pulse.
You can probably see it fluorescing.
Oh yeah, look at that. I can see that. Yeah.
So how do they measure these pulses? To measure an event, you need a shorter one. So, if you'd like to see what happens when a soap bubble pops, you need a strobe light that's shorter than the time it takes the bubble to pop. But then, how do you measure the strobe light pulse? You need an even shorter event. So now, how do you measure the shortest event of all? It seems you need an even shorter event, but that's something you definitely don't have, because the one you're trying to measure is the shortest event. To solve this problem, Rick came up with FROG. FROG is an acronym for Frequency Resolved Optical Gating. Because there's no shorter event, FROG uses the event to measure itself. It first splits the pulse into two, using a partially reflecting mirror. Then, by moving another mirror that one of them bounces off, back and forth, he can delay one pulse with respect to the other by a time he can calculate because he knows the speed of light. He then sends the two pulses into a crystal, which has an amazing property. When the two pulses overlap in time in the crystal, together they create a new beam of light. When they don't overlap, no new beam is created. He measures the new beam's energy and color for different delays, which tells him how the intensity of the pulse varies with time, and also how the color of the pulse varies with time. In short, FROG records a musical score of the pulse, just like musicians do for music, and this tells him everything he needs to know about the pulse.